Hey everyone, this is Megan Brett, and this is my video on instructional support tools of the Common Core standards. The first one we're going to start with is the mathematics, second grade mathematics. With these Common Core state standards in this document that we reviewed and went over, the reasoning is to increase student achievement by ensuring educators that they understand specifically what the new standards mean a student must know, understand, and be able to do. Also, it teaches us that in order to use this, we need to facilitate among teachers and curriculum staff and encourage coherence in the sequence, pacing, and units of study for grade level curricula, which we are doing second grade in this. So let's begin with the Common Core standards. We have 4 of them in the mathematics. We have operations and algebraic thinking, numbers and operations in base 10, measurement and data, and geometry. So in the first standard we have, which is 2.0A.1, which is second grade operations and algebraic thinking. In this standard, second grade students, they will extend their work with addition and subtraction word problems in 2 major ways. First, they represent and solve word problems within 100, building upon their previous work to 20. In addition, they also represent and solve 1 and 2-step word problems with all 3 types: the result unknown, change unknown, and start unknown. For example, if you have a 1-step word problem, there are 15 stickers on 1 page. Brittany put some more stickers on the page. Now there are 22 stickers on the page. How many stickers did Brittany put on the page? 1 step, you need to find the difference, so you would subtract. If there's a 2-step word problem, for example, there are 9 marbles, 9 blue marbles, 6 red marbles in a bag. And Maria put 8 more marbles in the bag. How many marbles does she have in the bag now? You would simply do 9 plus 6 plus 8 would equal to your answer. So you have more than 1 step there to do. The next Common Core standard in our operations and algebraic thinking, we have 2.0A.2. Building upon students' work in first grade, the second graders will use various addition and subtraction strategies in order to fluently add and subtract within 20. They will be counting on, making 10, decomposing a number leading to 10, using the relationship between addition and subtraction, and creating equivalent but easier or known sums. So they will internalize facts and develop the fluency by repeatedly using strategies that make sense to them. When our students are able to demonstrate fluency that are accurate, efficient, and flexible, they must have efficient strategies in order to know sums from their memory. So they need to retain all of that in order to keep going. Our third standard in our operations and algebraic thinking is 2.0A.3, which is where second graders will apply their work with doubles to the concept of odd and even numbers. Students will have ample experiences exploring the concept that if a number can be decomposed, which is broken apart, into 2 equal addends or doubles addition facts, such as 5 plus 5 equals 10, then that number, 10 in this case, is an even number. Students should explore this concept with concrete objectives, such as counters, cubes. Sometimes we use die to help with that. And before moving towards powerful representations, such as circles or arrays, which you would break down and say how many's in that array. And our next, which is our last standard in our operations and algebraic thinking, is 2.0A.4. And this is where our second graders will use rectangular arrays to work with repeated addition, a building block for multiplication in third grade. A rectangular array is an arrangement of things in rows and columns, such as rectangles of square tiles. Students explore this concept with concrete objectives. For example, they can use counters, bears, or square tiles, which I prefer, as well as a pictorial representation on the grid paper or other drawings. And due to the commutative property of multiplication, students can add either the rows or the columns and still arrive in the same solution. So if you have an array, you have a 3 by 4, you would times that 3 by 4 to equal how many is in total, which would be 12. Awesome. So now we are going to move to our next standard, which is number and operations in base 10. In this one, our first one is 2, which is second grade, NBT, numbers and operations in base 10, number 1. In this standard, what do our students mean a child will need to be able to know to do? Our second graders will extend their base 10 understanding to hundreds as they view tens as a unit called a hundred. So instead of the base 10, they'll now move to their 100 block cube, and they'll be able to recognize the difference between the base 10 and the hundreds blocks. They will use manipulative materials and pictorial representations to help make a connection between the written 3-digit numbers and hundreds numbers and ones. And in my school, we call those unit cubes. So we have our base 10 blocks, our hundreds blocks, and then our ones is called our unit cubes. In first grade, they also learned some of this, but with our second graders, they are going to have an understanding about hundreds. Also moves through several stages, counting by ones, counting by groups and singles, and counting by hundreds, tens, and ones. When they're counting by ones, at first, even though our second graders will have grouped objectives in hundreds, tens, and leftovers, they rely on counting all of the individual cubes by ones to determine the final amount. It is seen as the only way to determine how many in all. When they're counting by groups and singles, while students are able to group objectives into collections of hundreds, tens, and ones, they will now be able to tell how many groups of hundreds and leftovers there are. They will still rely on counting by ones to determine the final amount, but they are unable to use the groups and leftovers to determine how many there are altogether. Now we're going to move to our second standard in numbers and operations of base 10, which is N2NBT.2, which is counting within thousands, skip counting by fives, tens, and 100s. For example, what are the next three numbers after 498? You're going to count by ones. 499, 500, 501. But what about the next one? It asks, when you count back from 201, what are the first three numbers you would say? Which would be counting backwards. 200, 199, 198. So they're going to learn how to count by ones, fives, tens, hundreds, and thousands. Our next standard, which is 2, second grade, NBT.3. This is our third one. And this is where second graders will learn to read, write, and represent a number of objectives with a written numeral, which is a numbered form or standard form. These representations can include snap cubes, place values, which are our base 10 blocks, pictorial representations, or other concrete materials. And that has to be when they can do that while reading and writing whole numbers. The word "and" should not be used, so it should be written in number form with no "and" in between. And they will also learn expanded form. When they have a written number in digit form, 125, they need to know how to break that number apart into place values. So they will break it up into hundreds, tens, and ones places. So if you have the number 125, you would write it out in expanded form. 100 plus 20 plus 5 equals 125. Our last standard in this standard, which is second grade NBT, Numbers and Operations, Base 10, number 4. In this standard, they will learn that they will build on their work of the first standard and the third standard by examining the amount of hundreds, tens, and ones in each number. When comparing numbers, our students draw on the understanding that 100, the smallest three-digit number, is actually greater than any amount of tens and ones represented by a two-digit number. When students truly understand this concept, it makes sense that one would compare three-digit numbers by looking at the hundreds place first. Our students should have ample experiences communicating with their comparisons in words before using symbols, such as greater than, less than, or equal to. If you have 452, is that less than, greater than, or equal to 455? That is less than. So they need to learn the less than, greater than, and equal to symbols. Now we will move on to our third standard, which is measurement and data. I'm sorry, let's go back. I missed one of the standards. We have second grade NBT 5. We have one more, where students are going to fluently add and subtract within 100 using strategies based on place value, properties of operations, and or the relationship between addition. For example, if you have 67 plus 25, they need to find the place value. There are various strategies that second grade students understand and use when adding and subtracting within 100, such as those listed in the standard. And the standard algorithm of carrying or borrowing is neither an expectation nor a focus in second grade. Students use multiple strategies for addition and subtraction in grades K through 3, and by the end of third grade, students use a range of algorithms based on place value, properties, and operations, and or the relationship between addition and subtraction to fluently add and subtract within the thousands place. Students are expected to fluently add and subtract multi-digit whole numbers using the standard algorithm by the end of third grade. Our next one, which is 2, second grade NBT 6, the sixth one, which is where second grade students add a string of two-digit numbers, up to 4 numbers, by applying place value strategies and properties of operations. For example, 43 plus 34 plus 57 plus 24 equals. They will have two-digit numbers in a line where they have to figure out, okay, we need to start with our ones place value, start with our ones place, figure out our total here, carry our remainder, add it to our tens place. So they will learn that strategy as well. Second grade number and operations in base 10, number 7, is where second graders extend the work from the 5th standard to 2 3-digit numbers. So they're moving up from 2-digit numbers, adding and subtracting, to 3-digit numbers where they're going to increase a number. So they have ones place, tens place, and hundreds place that they will learn to add and subtract with. Students should have ample experiences using concrete materials and pictorial representations to support their work. So, for example, we could set up a hundreds place base 10 and a unit cube to show that they could write it in expanded form, or they could do it with the digit form and then they'd add and subtract, whichever was asked at that question. Now we're going to move to second grade numbers and operations in base 10, number 8, where second grade students mentally add or subtract either 10 or 100 to any number between 100 and 900. As teachers provide ample experiences for students to work with pre-group strategies and facilitate discussion, our second graders realize that when one adds or subtracts 10 or 100, that only the tens place or the digit in the hundreds place changes by 1. As the teacher facilitates opportunities for patterns to emerge and to be discussed, students notice the patterns and connect the digit change with the amount changed. So opportunities to solve problems in which students cross hundreds are also provided, and once students have become comfortable adding and subtracting within the same 100. Now we're moving on to second grade numbers and operations in base 10, number 9. This is where second graders explain why addition or subtraction strategies work as they apply their knowledge of place value and the properties of operations in their explanation. They may use drawings or objects to support their explanation, so they will have a pictorial example that they will set up. And once students have had an opportunity to solve a problem, the teacher, which is I or you, will provide time for their students to go up and discuss the strategies and why they did or didn't work. If they got it wrong, they need to explain what the step was that they didn't do correctly and how it is that they can correct it. And then we move on to measurement and data. This is the next Common Core standard that they have listed, and that is starting with the number 1, which is second grade MD, which is measurement and data, number 1. In this one, second graders build upon their non-standard measurement experiences in first grade by measuring the standard units for the first time. Using both customary inches and feet and metric centimeters and meters units, second graders select an attribute to be measured: length of the classroom, width of the door, height of the door. It just depends on what you can utilize in your classroom. And choose an appropriate unit of measurement, such as a yardstick, and determine the number of units, yards. As teachers provide rich tasks that ask students to perform real measurements, these foundational understandings of measurement are developed. They understand the larger units can be subdivided into equivalent units. They understand that the same object or many objects of the same size, such as paper clips, can be repeatedly used to determine the length of an object. And they also understand the relationship between the size of a unit and the number of the units needed. Thus, the smaller the unit, the more units it will take to measure the selected attribute. Our next one, second grade MD, measurement and data, number 2. Measure the length of an object twice using length units of different lengths for 2 measurements. They will also describe how the 2 measurements relate to the same size of the unit chosen. For example, a student measured the length of a desk in both feet and inches. She found that the desk was 3 feet long. She also found that the desk was 36 inches long. So, as the teacher, I would say, why do you think you have 2 different measurements for the same desk? Hopefully the student would say, it only took 3 feet because the feet are so big, but it took 36 inches because an inch is a whole lot smaller than a foot. Our third, second grade, measurement and data, number 3. Second grade students estimate the lengths of objects using inches, feet, centimeters, and meters prior to measuring the estimation, which helps the students focus on the attribute being measured and the measuring process. As students estimate, students have to consider the size of the unit, helping them to become more familiar with the unit size. In addition, Estimation also creates a problem to be solved rather than a task to be completed. They have more experience and more hands-on experience. And myself, I'm more of a hands-on learner. If I can do it myself, I learn it quicker than reading it out of the book. So once a student has made an estimate, the student then measures the object and reflects on the accuracy of the estimate made and considers this information for the next measurement. Second grade measurement and data number 4. Second grade students determine the difference in length between two objects by using the same tool and unit to measure both objects. Students choose two objects to measure, identify an appropriate tool and unit, and measure both of the objects. Then they will determine the difference in lengths. Now we move on to second grade measurement and data number 5. Second grade students apply the concept of length to solve addition and subtraction word problems with numbers within 100. Students should use the same unit of measurement in these problems. Equations may vary depending on students' interpretation of the task. Notice in some of the examples that are provided below that these equations are similar to those types that they have already demonstrated, such as in PE class, Kate jumped 14 inches, Mary jumped 23 inches. How much farther did Mary jump than Kate? They have to write an equation, so they can use their base 10 blocks along with their unit cubes to figure out a pictorial and written expression for it. Second grade measurement and data number 6. Building upon their experiences with open number lines, second grade students create number lines with evenly spaced points corresponding to the numbers to solve addition and subtraction problems to 100. They recognize the similarities between a number line and a ruler. For example, there were 27 students on a bus. 19 students got off the bus. How many students are on the bus now? So you would have a number line written, shown example on the board from 1 to 30. If you have 27 students in all, you show an example of how to do that. Have the 27 students mark off and count backwards and find the difference to find out how many students were on the bus now. Second grade measurement data number 7. Well, this is where second grade students extend their work with telling time to the hour and half hour in first grade in order to tell orally and in writing the time indicated on both analog and digital clocks to the nearest 5 minutes. Teachers help the students by making connections between skip counting by fives, and how telling time to the nearest 5 minutes on an analog clock. How it's the same. When you have to tell the minute, you count by fives. So you practice your counting by fives first, and then help them show how they can do that on the clock. Second grade measurement data number 8. In second grade, students solve word problems involving either dollars or cents. Since students have not been introduced to decimals, problems focus on whole dollar amounts or cents. This is the first time money is introduced formally as a standard. Therefore, students will need numerous experiences with coin recognition and values of coins before using coins to solve problems. Once students are solid with coin recognition and values of coins before using, they can then begin using the values of coins to count sets of coins, compare two sets of coins, and select coins for a given amount and make change from those amounts. Our next standard is second grade MD number 9, measurement data number 9. Second grade uses measurement data as they move through a statistical process of posing a question, collecting data, analyzing data, creating representations, and interpreting the results. In second grade, students represent the length of several objects by making a line plot, and students should round their lengths to the nearest whole unit. For example, measure 8 objects in the basket to the nearest inch. Then display your data on the line plot. So, my question to my student would be, what do you notice about your data? And I would hope they would say, most of the objects I measured were 9 inches. Only 2 objects were smaller than 4 inches. And they were surprised that none of their objects measured more than 9 inches. Our next one in this, which is our last one, second grade measurement and data number 10. In second grade, students pose a question, determine up to 4 categories of possible responses, collect data, represent data on a picture graph or bar graph, and interpret the results. This is an extension from first grade when students organized represented data and interpreted data with up to 3 categories. They are able to use a graph selected to note particular aspects of the data collected, including the total number of responses, which category had the most, the least responses, and interesting differences, similarities between the 4 categories. They then solve simple one-step problems using the information from the graph that they had as a pictorial representation. Our last standard is in geometry. Now we're moving on. There are 3 different kinds in this geometry standard. 2 second grade geometry number 1. Second grade students identify, recognize, and name shapes and draw shapes based on a given set of attributes. These include triangles, quadrilaterals, which are squares, rectangles, and trapezoids, pentagons, hexagons, and cubes. Second grade geometry number 2. Second graders partition a rectangle into squares or square-like regions and then determine the total number of squares. This work connects the standard 2-point operations and algebraic expressions number 4, where students are arranging objects in an array or rows and columns. And this standard is a precursor to learning about the area of a rectangle and using arrays for multiplication. Second grade geometry number 3. Second grade students partition circles and rectangles into 2, 3, or 4 equal shares or regions. Students should be given ample experiences to explore this concept with paper strips and pictorial representations. Students should also work with the vocabulary terms halves, thirds, half of, third of, and fourth or quarter, especially when you're working on that standard where you're telling time. Once they've grasped the concept of counting by fives and representing the minutes in terms of fives, then you can go and help them learn quarter till or quarter after, and that'll help along with that as well. And while students are working on this standard, you should help them to make the connection that a whole is composed of 2 halves, 3 thirds, or 4 fourths. And this standard also addresses the idea that equal shares of identical wholes may not have the same shape. And that is all of our math standards, which are very important in implementing education and teaching second grade, which helps us keep a track of everything when it comes to teaching the students. Now we're going to move on to our instructional support tools for achieving standards in essential standards for second grade science. The purpose of this document is to increase student achievement by ensuring educators understand specifically what the new standards mean a student must know, understand, and be able to do. In this document, there are descriptions of what I'm going to tell each of you, and each standard means a student will know, understand, and be able to do. So our first second grade science standard, we have 2.P.1, which is where the forces and motion, and students will understand the relationship between sound and vibration of different objects. Students know that vibrating objects produce sound. Students know that sound can be described in terms of pitch, which may be higher or lower, and students know that length of an air column determines if it's pitch, if it's high or low. They will also know that the shorter the air column is, the higher the pitch is going to be. And students will also know that the longer the air column is, the lower the pitch is going to be. In 2.P.1.2, students know parts of the body vibrate in order to produce and receive sound. Our voices produce sound when air in the lungs passes over our vocal cords and makes them vibrate. The pitch and volume of the sound humans can produce are changed by changing the properties of the vocal cords. Students will know that sound waves are collected by the outer ear, which helps to funnel sound to the eardrum. The eardrum vibrates when sound waves hit it and causes the tiny bones in the middle ear to vibrate as well. The vibrations move through the bones to the inner ear, where sounds are changed into a form that is understood by the brain. Our next one we have is matter, the properties, and change. 2.P.2, understand properties of solids and liquids and the changes they undergo. 2.P.2.1, students will know that solids are materials that maintain their own shapes, while liquids tend to assume the shapes of their containers. Students will know examples of materials that can be classified as solid and materials that can be classified as liquid. Students will know water can be liquid or solid and can go back and forth from one another to the other when heat is added or removed. For example, you can have candle wax. When you have the candle on the warmer, it's going to turn into liquid. When the candle is put out, the warmer is cut off, the wax is going to go back into a hardened form. 2.P.2.2, students will know how to measure and compare the volume of a liquid poured into different containers. They're going to learn a form of measurement, which is going to relate back to our math skills. Students will know how to measure and compare the weight of water poured into different containers. And they will know if water is turned into ice, then the ice is allowed to melt. The amount of water is the same as it was before freezing. In 2.P.2.3, students will know how to measure and compare the volume of liquid poured into different containers. Students will know that a container of water left open will contain less water over time, while a closed container of water will not change because of evaporation. And they will also learn the terminologies with these as well. Our next one is Earth systems, structures, and processes. We have 2.E.1.1. Students will know that light travels from the sun to the earth, and some of this light is reflected back into space. Some of it is absorbed by the land, water, and air. In 2.E.1.2, students know that the numbers are used to describe air temperature, wind speed, and the amount of precipitation that occurs. Students will know that wind direction is described using cardinal directions, north, east, south, and west, and in numbers. Students will know how to measure air temperature with a thermometer, wind direction with a windsock or vane, wind speed with an anemometer, and precipitation with a rain gauge. You'll learn how to measure those. In 2.E.1.3, students will know that over time there are patterns that can be observed in the weather, and these patterns are influenced by the time of day, which is cooler morning, warmer afternoon, and the time of year, seasonal changes. In 2.E.1.4, students are familiar with the manual and electronic weather instruments, sensors, and computers, as well as they can produce a running record of weather changes that occur over time by collecting and recognizing the data. This collection of data can be analyzed as a basis for predicting weather trends. Now we're going into structures. Bagheera! No, ma'am. I'm sorry, guys. I'm babysitting dogs today, and she's wanting to chew on my table. No, ma'am. Come here. Now let's try this again. I'm sorry. Structures and functions of living organisms. We have 2.L.1. Understand animal life cycles. We have that students will know that animals experience a cycle of life which begins with birth, then a period of time in which the animal develops into an adult. So they'll learn that life cycle change, how they come into the world, how they grow up, and how they leave the world. At adulthood, animals reproduce in order to sustain their species. In nature, all animals are programmed to age and eventually die. The details of the life cycle are different for specific animals. In 2.L.1.2, students know that different animals spend varying periods of time in each stage of the life cycle, and that some animals have few stages, while other animals have several, such as the monarch butterfly. They only have a few weeks lifespan, whereas you have, in our lifespan, we have multiple years. Bagheera, no ma'am. I'm sorry. Alright, so let's move on to evolution and genetics. We have our first one, 2.L.2.1. This is where students know that plants and animals resemble their parents in appearance, needs, life processes, and interactions with the environment, even while being unique. And our last one in our science is 2.L.2.2. And this is where students know that groups of organisms of the same type have characteristics in common as well as characteristics that may vary. I believe that all of these standards are important in helping our students understand life cycles in science, mathematics, how they can use the operations in algebraic thinking, numbers and operations in base 10, measurement and data in geometry, and how these all apply to our everyday lives. I thank you so much for watching my video. Hope you have a great day. Thanks.